Hey guys, welcome. Mr. Larson again. Hey, I'm going to go through some 5.1 notes with you today. This is some of my favorite stuff. It can be really tricky for students, but I encourage you guys to just kind of hang in there with this. It's going to be really challenging at first, and I think that a lot of you guys will enjoy it as we kind of go, even though it is challenging. What we're going to basically do is look at some different trig expressions. So these are kind of some examples that you'll see. And our goal is to, using the identities that I'm going to give you that we know most of already, we want to transform these into an equivalent value that's basically one term. So one trig function, or sometimes it comes to be one constant. Okay, and I'll kind of show you what that looks like as we work through here. But go ahead and pause it. Let's go ahead and get these identities down. We know all of these reciprocal identities already. We've talked about the quotient identities. And then the last part that's kind of new is the Pythagorean identity. So go ahead and get these down, and then you can unpause when you do. Okay, so the Pythagorean identities, the first one we'll take as a given. You have to memorize that one. So sine squared of x plus cosine squared of x equals 1. That'll be true 100% of the time as long as you're plugging in the same angle measure for x, right? So sine squared of an angle plus cosine squared of that same angle is going to simplify to just be 1. So there's two other Pythagorean identities that we're going to use, and I don't want you to memorize these, but I want you to be able to derive them. I want you to be able to figure them out from the original sine and cosine one. So if we take the sine squared plus cosine squared equals 1, and if we divide everything, so both sides, by sine squared of x, which I'm allowed to do as long as I do it on both sides, this is going to give me a separate identity. So sine squared over sine squared is 1. Cosine squared over sine squared, well, cosine over sine is cotangent, right? Cosine over sine right here is cotangent. So if I'm just squaring the top and bottom and doing cosine squared over sine squared, that identity works the same. It's just cotangent squared of x. And then 1 over sine squared, well, 1 over sine is, where are we? Cosecant. So 1 over sine squared would be cosecant squared of x. So here's a second Pythagorean identity. And then for a third one, let's go back to the original one, and instead of dividing by sine squared, let's divide by cosine squared of x on both sides. So let's see, sine squared over cosine squared gives me tangent squared of x. Cosine squared over cosine squared is 1, and then 1 over cosine squared should give me secant squared of x. So please make sure you get those down. These are the identities that we're going to use, Pythagorean, quotient, and reciprocal identities. All right, so here's how these are used. So I'm going to go through and get as many of these done as I can, and then what I'm going to do on each one, which is good practice for you, is just write down the type of identity that you use to simplify. So 1 over secant squared, we don't want any fractions when we're done simplifying. So I would take this and I would say, oh, I recognize that as a reciprocal identity. That's really equal to cosine of x. So we will simplify to cosine of x. And then up here I'm just going to write that I used a reciprocal identity. All right. It works the same way even if your numerator is something other than 1. So for number 2, if I look at that, we can think of that as 2 times, like if I factor out the 2, 1 over sine of x. Of course, 1 over sine of x is cosecant, so this gives me 2 times cosecant of x. So again, I use the reciprocal identity to solve that. All right. Tangent of x times cotangent of x. Let's see. I know that tangent is really sine of x over cosine of x. I know cotangent is cosine of x over sine of x. Right? That's using quotient identities. And now I have sine over sine, cosine over cosine. That's going to simplify to just be 1. So what did I use? I used quotient identities, right? We're just finding equivalent values. All right, number 4, sine of x. Can't really do anything with that. Plus cosine of x times tangent of x. Sine of x plus cosine of x. I know tangent of x is really sine of x over cosine of x. So that's using a quotient identity. Not done yet, but let's write quotient. And then let's see, I have cosine over cosine. So I'm left with just sine of x plus sine of x over 1. And that's just going to give me 2 times sine of x. Not sine squared, because they're added, but 2 times sine of x. So the only identity I used was a quotient identity to change tangent to sine over cosine. All right, what else we got? Sine squared of x plus cosine squared of x. Well, that's really just my original Pythagorean identity. That's equal to 1. So I use Pythagorean identity. Secant squared of x minus 1. So here's a hint. Anytime you see some squared terms, it's not 100% of the time, but it's usually a good indicator that you're going to use a Pythagorean identity. If we take a look back at this first page, nothing has squared terms other than the Pythagorean identity. So that's the first thing I would check out. It doesn't guarantee that it'll get you to where you need to go, but most of the time it's going to help you. So let's see, secant squared of x minus 1. Do I see... The nice thing is that every squared trig function only occurs once in a Pythagorean identity. So I want to look for the one with secant squared. It looks like right here I have secant squared, but I don't have secant squared minus 1. So here's the thing. You can use these identities and manipulate them using your addition and subtraction properties. So if I look at this identity, if I subtract 1 from each side, what am I left with? I'm left with tangent squared of x on the left is equal to secant squared of x minus 1. So this is what I'm seeing in my expression down below. I think it was number 7 or something. I can use this original, with the blue box around it, the original Pythagorean identity, manipulate it and get that secant squared of x minus 1 is equal to tangent squared of x. So where was I? Number 6. Secant squared of x minus 1 is really tangent squared of x. And I'm using a version of one of the Pythagorean identities. So you might have a little bit of work to do before those work for you. Okay, so let's take a look again at the types of expressions I'm being left with. I had 1, that's one term, right? I had tangent squared of x, that's one trig function. Happens to be squared, but it's one trig function. For number 3, I got 1. For number 4, I got 2 sine of x. That's one trig function, just with a coefficient, right? Cosine of x, 2 cosecant of x. So hopefully you can see that we're simplifying to one nice term. Sometimes it's a constant, sometimes it's a trig function with a coefficient, sometimes trig function squared, that type of stuff. So number 7, sine of x times secant of x. One thing that's really nice is that every single trig function of all 6 of them, every single one of them can be changed to either sine or cosine or something involving sine or cosine. So like secant of x, if I'm not really sure where to go, I might just change that to 1 over cosine of x. If you can change everything to sines and cosines using identities, that can be pretty helpful. So let's try that. Sine of x times 1 over cosine of x. So I'm not done yet, but let's simplify that. That's going to give me sine of x over cosine of x. Oh, I see an identity there. That's our reciprocal identity. That is really equivalent to tangent of x. So first I did a reciprocal, And then I used a quotient identity. So you can use multiple of these. Some of them, we might have to use 3 or 4 different identities. I think that's the first one where I used multiple. If you guys are still following along here, I encourage you to stop. Go try some. I think you've seen enough where you can probably figure some of these out. And then you can come back and see me work through them if you need to. Let's see. Again, I'm going to change to all sines and cosines. So sine of x over cosine of x times sine of x over 1 plus cosine of x over 1. So let's multiply this first one together. So I get sine squared of x over cosine of x plus cosine of x over 1. Well, I need to get one term, right? So really I need to combine these fractions somehow. I think if I get a common denominator of cosine, then I can hopefully add those together. So cosine of x times cosine of x is cosine squared. So I get sine squared of x plus cosine squared of x all over cosine of x. So let's see, first I did, well, let's keep simplifying. Do we agree that this part's going to be equal to 1, right? So this is really 1 over cosine of x, which gets me secant of x. So we did a lot there. We did reciprocal. Then we did Pythagorean identity. And then I did another, I'm sorry, the last one was reciprocal. This one was our quotient. So we did quotient as well. That was first. So I used all 3 types there. Okay. Number 9. My favorite thing to do is change everything to sines and cosines. I usually find luck with that. So we could try to use a Pythagorean identity on the bottom. Maybe I'll come back, and if I can't figure it out, I'll start over and do that. But my first thing I want to try is changing everything to sines and cosines. So I have cosine of theta times cosecant's really 1 over sine of theta. That's all over cotangent squared of theta. Cosine times 1 over sine, that's really cosine over sine over cotangent squared of theta. So let's see, cosine over sine, that's cotangent over cotangent squared. Okay, so I have cotangent over cotangent times cotangent. So I think the cotangent and one of them from the bottom are going to offset, right? And that's really equal to tangent. Okay, so let's see, we did reciprocal, right? I did reciprocal first. Then I did quotient. And then I did, that step was another reciprocal. Okay, so you guys have some left that you can try. I got through a little more than half. They do get tricky, but do your best. And remember, use the identities. If you're not sure, you can also change to sines and cosines. What else did we do in there? We found a common denominator so that we could add fractions. Yeah, do your best. I expect it to be challenging, but after this, try the homework, and we'll get some more practice on this stuff next time we see it as well. All right, thanks, guys.